So now we're going to write some code that's going to allow the assembly language machine itself to execute a selection sort, making use of all of the techniques we've learned already. So array access and subroutines and conditionals and loops and all that kind of stuff, all getting put together. It's a really great summarizing example for the whole second half of the course. So what we're going to do is we're going to have a list that's going to start from 0 and go to n minus 1. We're going to search through the entire list. We're going to find the largest number on the list, and we're going to swap it with the last element in the list. And then we're going to do it again for a list that's one less and one less and one less and one less until we only have one element left, and then we're done. So we're maintaining two pointers, one pointing to the first element in the list, one pointing to the current last element in the list. And that way, each time we go through this process, we can move that last element up by one, have a shorter list to search through, and then we know we're almost there. So what we're going to do in this code example is I'm going to walk through and show you sort of how some good practices for the code and also explain exactly what everything does. What I like to do is at the beginning of my code, I like to give a list of the registers that I'm using and what I'm using them for. This is all in comments. This isn't used by the machine to do anything. It's to remind me what I'm doing. So we're going to use A0 to point to the first element in the unsorted part. We're going to use A1 to point to the last element in the unsorted part. And then I'm going to use those A registers as arguments to a subroutine that's going to find the index and value of the maximum element in the list indicated by those two pieces. So it's sort of like a mutable array, right? There's pointer to the beginning, pointer to the end, and then you can carry on and look through the whole thing. Then I'm going to have V0 be the pointer for the max element in the unsorted part, and V1 be the value of the max element in the unsorted part, so that when I'm done that subroutine, I could just swap the element I found with the last element, and then I know that I'm in that element has been sorted. Okay? So this is what the sort subroutine or the sort program looks like. First of all, I'm going to check and see if the pointers are the same. That's going to be my exit condition. Because if I start with the pointers being the same, that means that my list has 0 elements in it and I'm done. Okay? If my pointers aren't the same, so if my pointers are the same, then I'm done. Right? And then I can exit my program. If my pointers aren't the same, then I'm going to call my max subroutine. And that max subroutine, I will have already set the pointers A0 and A1 to their current values at the beginning and the end of the array. And then I'm going to expect that after we're done this subroutine, V0 and V1 are going to contain the max element indications for the rest of that procedure. I'm not using a stack frame for this because I know that the max is going to be a terminal subroutine, and I know that I only need a couple of arguments and a couple of return values, so it's sufficient to use the register procedure call rather than all of that stack frame stuff we did before. You could, if you wanted to, rewrite this to use a stack frame. That would be a nice question on an exam. Here's a procedure call that uses registers. Rewrite it so it uses a stack frame. But we're not doing that right now. So then we jump to the procedure. When we come back from the procedure, the V0 and V1 are going to have our results. So what I'm going to do now is I'm going to swap the element, the max element that was found using this procedure with the last element, which I know A1 is pointing to, right? A1 is pointing to the last element. So I'm going to swap the last element. So A1, the element that's in A1 gets into T0. That's my temporary value. And then I'm going to store that value to the location that the maximum value was at, and I'm going to store the maximum value to my location that the last element is at. So I'm moving them around. I'm swapping the maximal element for the last element. And then I'm going to move my pointer to the last element up by 4, which moves it to the sort of next element up in the array. And then I'm going to do it again, right? And then during this process, I've changed my value of A so that this test condition can be different, right? If I haven't changed anything in this test condition would never change, and I'd be hooped. It would be an infinite loop. But since I've changed this test condition, now I can go back and check and see what's happening here. Maybe they're the same, and I'm done. If they're not the same, I do the same thing again. I find the maximal value, swap it with the last value, and then subtract 4 and see what happens. So what does the max subroutine look like? These are the registers that I'm using in the max subroutine. I'm going to be expecting arguments in A0 and A1 for the pointers to the first and last element in the array. I'm going to have a register T0, which is going to point to the next element that I'm considering. I'm going to have T1 that's going to be the value of the next element that I'm considering. I'm going to have T2 will be the result of whether the next number that I've looked at is smaller than the maximum number. And then, because if it is, then I leave it alone. If it isn't, I'm going to swap it so that I now have a new maximal number. It's sort of the other way of looking at it, but again, we have set less than as a real instruction rather than set greater than. So this is a sort of a cleaner way to write it, even though the comparison can be confusing. And then V0 and V1 are going to be my pointer and value to the max element that I'm going to generate as a result of this subroutine. So let's look at the subroutine. Here's the code. And again, this just giving you the code is intimidating and frustrating, but if you were to take your time and sit down and write it, you would understand every single one of these instructions and why and how to use them. And this is going to be the key for you getting a good mark on the final exam, is being able to write assembly code. So here we go. So when we first enter the max subroutine, if this was a stack-based subroutine call, I'd need all sorts of stack stuff here, frame pointers and stack pointers. But because I'm just using the registers to pass parameters, I can save all of that stuff and not even touch the stack. So this is a big efficiency that you can get when you use a register-style procedure call over a stack-based procedure call. Okay, so first of all, I'm going to initialize the max pointer. That'll say I want to set my first value, or set my maximal value to my first value. And then I'm going to check each subsequent value and see if it's bigger, and if it is, replace that. So my first value is my first maximum value. Then I'm going to, that's my first pointer, and that's my first value of that pointer. I'm going to load that value into V1. So I'm going to say V1 is going to be where my maximum value is going to be. V0 is going to be where my pointer is going to be. Then I'm going to initialize my next pointer to my first value. And I'm going to, so the reason I'm initializing it to the first value is in the context of the loop, I'm going to go to the next value, check, next value, check. So first thing I'm going to do is check if my loop has finished. If my pointer is at the end of my array, then I'm done. So this is the sort of pointer that's in the middle of the array that I'm walking through. And if it equals the end of the array, then I'm done. If not, then I carry on. So that if I'm done, I jump to the return, and the return is just JRRA, and I'm done. So then I'm going to advance to the next element. So this is why I started at the first element, so I could test if it was true and then advance to the next element. Where to do those tests and how is a really important and difficult thing to decide how to do. Then I'm going to load the next element, and I'm going to set T2 if T1, which is my next value that I'm looking at, is less than my max. And if it's not, then I'm done. And if it is, then I'm going to set that as my new value. Okay, so if it's not less than, which means it's greater than, then I'm going to repeat with the next value with no change, right? Repeat with no change. Then, so that's if it is in fact less than, then I'm going to repeat with no change. And if it isn't less than, then I'm going to say that my new value for V0 is where I'm at, and my new value for the pointer, my new value for the pointer is where T0 is, and my new value for the value of the maximal value is where T1 is. So I'm going to set my new maximal values, and then I go back to the beginning of the loop again. I'm going to make another video that walks through this code with an example of the memory beside it, so you can walk through exactly how this all works. So that's the full code. There's another example here that we'll look at as a maximum sum prefix, which is another thing you can look at. I'm going to leave this in the notes for you to have a look at yourself. But I'm going to do one more video with this code that's going to walk through the contents of the array with an example and show you exactly how it works.